Hello, hello everybody. This is your practice problems video for segments in circles. So that's secants, tangents, and chords. All right. So I have 8 problems for you here. I'm going to do a couple and then I'm going to have you try a few on your own. All right. So let's go ahead and jump into it here. All right. So these first couple of questions that you see on the screen deal with that first tangent property where you can always have one radius and a tangent that are perpendicular to each other. Oops, oh dear. One moment. Sorry, folks. My computer's doing something silly. Here we go. Okay, so let's look at number 1. This says, given in this image here that OT is 4, YT is 8, and OY is 10, is XY tangent to circle O at point T. Now, if I just draw this, right, if I draw the radius to this tangent, it looks perpendicular, right? But I have to verify that it actually is perpendicular using the information that I have, right? Because not everything that's drawn is to scale, right? That's why we have to use the math to actually verify that it's true, okay? So I have OT is 4, so I'm gonna go ahead and label that. YT is 8, okay? And then they said OY, which I haven't drawn in, but I will, is 10, okay? So if this is perpendicular, right? If it is tangent, then that means these two segments, OT and YX, are perpendicular. So that means this triangle right here has to be a right triangle, okay? Well, we have tools in order to determine if 3 side lengths actually give you a right triangle. So if you recall, we have our converse of the Pythagorean theorem to check to see if side lengths that are given to us actually form a right triangle. So that's what we're going to do here, okay? So C is my largest number, which is 10. So I have 10 squared. You know, when I do these, I normally put a little box right here, just so that that way because I don't know if it's an equal to or less than or greater than symbol. Okay, then usually we make A the smallest number, so that would be 4. So 4 squared plus, and then B is my second smallest number, so 8. Right, so 10 squared is 100. Right, 4 squared is 16, and 8 squared is 64. Okay, so if I actually go and add those together, so I have 100, and then on the right side of the equal sign, I have 80, right? So these are not equal, right? The C squared value is greater than the A squared plus B squared value. So what that means is that that triangle is not a right triangle. So that radius is actually not tangent to not tangent as shown in the image, right? So XY is not tangent to the circle at point T. So no, and my reason why is the side lengths given don't form a right triangle. And then I'll just put in parentheses for you all, according to the converse of the Pythagorean theorem. Okay. All right, so that's number 1. All right, number 2 is a similar idea, but at this time, I'm actually telling you that yes, this is a tangent. Okay, I told you that the radius of circle P is 8, right? And I'm hoping that you can see in the image, I have 2 radii here, AP, so that has to be 8, and PB also has to be 8. Okay, and then I told you that BC is 9, right? And then my goal here is to find AC. Since I know these are tangent, I know this is a right triangle, all right? So what I'd love for you all to do, now that you have this filled in, is give this a try and see if you can solve this, right, using the Pythagorean theorem to figure out what x is, okay? So pause the video and then check back with me to see how you did. All right, y'all, so go ahead and check your answer against mine. So since we're dealing with a right triangle here, I'm going to use the Pythagorean theorem. I know that if PB is 8 and BC is 9, then the whole thing is 17, and that's my hypotenuse. I can tell because it's across from the right angle. Okay, so I know my C value is 17, and then I'm going to say my A value is 8, so I'm looking for my B value, right? So I just plug those numbers into my Pythagorean theorem. So I have 8 squared plus x squared equals 17 squared. I squared 8 and 17, subtracted the 64 over to the other side in order to get x squared by itself. I got x squared is equal to 225. Taking the square root of that number, I get that x is equal to 15, right? And then because I had units in my problem, I wanted to make sure that I gave units in my answer, all right? Okay, so let's take a look at number 3 right here. Okay, so in this one, it's very important that we do some drawing here, okay? So they say the chord of a circular clock is 12 inches long. Okay, so let's go ahead and draw a chord. I'm just going to draw it straight across the top. Okay, so that chord is 12 inches long, okay? Then they said its midpoint is 8 inches away from the center. Okay, so the midpoint is here, right? Right in the middle of that chord, and it is 8 inches away from the center. Okay, and then the question here is to find the length of the radius. Okay, so my radius, I can draw lots of different radii here, but I think the one that's going to help me the most is if I draw from the center out here, right? So that's my radius, and that's what I'm trying to find. Now, if you think back to some of our chord properties, okay, we know that this, because it's a midpoint right here, it's like having a diameter that's intersecting a chord, right? So remember, one of our properties was that if that happens, that means the chord is bisected, it's cut in half, right? So what that means is if the entire thing is 12, okay, then that means each of these would have to be 6. So what I have going on here is a right triangle where I know that one side is 6, one side is 8, and I'm looking for my hypotenuse here. Now, I could go through and plug this into the Pythagorean theorem, right, and go through and solve that whole thing, but I'm hoping that you recognize that this is a 3, 4, 5 triangle multiple, right? 3 times 2 is 6, 4 times 2 is 8, so 5 times 2 will give me my C value, right? So just for the sake of time in doing this video, I'm not going to work out the entire Pythagorean theorem here. You can if you wish, but I'm going to do this based on my 3, 4, 5 triangle. So one leg is 6, the other leg is 8, then that means my hypotenuse has to be 10, right? And again, because they gave me units in my problem, I'm going to put units in my answer, okay? All right, so let's switch gears a little bit and look at a slightly different chord property here on number 4. Okay, so this chord property that I'm looking at for number 4 is the third chord property that I told you about in the notes video. Okay, and that property is if you have two chords that intersect, then that means you can take the two parts of one chord and multiply them together. Right, so I'm going to put a little like times symbol right there. Okay, and I can do the same thing with the two parts of the other chord, right? Multiply those together, and they have to be equal to each other. So what I have here in this image is I have 4 times 49 has to equal, I'm trying to keep track of my colors here, has to be equal to x times x, right? Well, 4 times 49 is 196, okay? And then x times x is x squared, right? So now, since I just have x squared, all I have to do is take the square root of both sides, and that's going to give me my x value. Okay, so here, right, square root of 196 is 14. So that is my x value, right? Okay, so for number 5 and 6, I want you to see if you can do 5 and 6 on your own. Since we've done in number 3 and number 4, you've seen all of the ideas that will help you find your missing values, okay? Or help you draw what's going on. So in number 5, you have to find x and y. Okay, notice you have a right triangle here, so that's going to help you find x, but you're going to have to use this rule from number 4 to help you find y first, okay? And then for number 6, all you have to do here is draw what's happening. Notice that we're talking about a diameter that bisects a chord, right? Because you have points A and B that lie on the circle, right? So all you have to do here is draw and classify the triangle that's formed by those points, right? And I'm hoping that just looking at number 3, you kind of already have an idea of what kind of triangle you're dealing with, all right? So give 5 and 6 a try, pause the video, give 5 and 6 a try, and then check back with me to see how you did. Alrighty, folks, go ahead and check your answers against mine. So I told you for number 5 that you needed to figure out what y was first in order to figure out what x is, right? Because x is the hypotenuse of that right triangle that you see drawn on the screen. But I need to know what y is first, right? So that I can get the other leg before I can figure out what that hypotenuse is. Okay, and to do that, I'm using the chord multiplication rule. Okay, because you have 2 chords here, right? This one and this one, right? So I know that I can multiply the 2 parts of each of those chords together, right? So the 16 and the 16 and the 20 and the y, right? I can multiply those together and set them equal to each other, and that will help me find y. So that's exactly what I did, and that's what's written there in orange. Okay, so 20 times y equals 16 times 16. So you have 20y equals 256. I divided by 20 on both sides to get the y by itself and got that y is equal to 12.8. Okay, so now that I know that y is equal to 12.8, I can use it in my Pythagorean theorem in order to figure out what x is, right? So that y became like my a for a squared, 16, right? This part, 16 from here to here, okay, is my b squared, and I'm looking for c squared, which is my x, okay? So you go through and do all of the math, right? I squared everything, added these up, and took the square root and got that x was equal to 20.49. Okay, now I want to point this out to you because I think this is a really good example of how pictures can be deceiving, right? If you look at this, right, you have this x value is about 20.5, right? But it's much shorter than this length, which is supposed to be 20, right? So that's important to keep in mind, right? And like I said, it's a good example of how pictures are not always what they seem, right? And you have to verify things with the math, okay? So for number 6, this was another place where you had to draw, okay, and do some drawing. So I'm hoping that your drawing looks a lot like mine here on the right. It should look very similar to the drawing that we did in number 3, okay? So we have a diameter of the circle, which I have drawn in blue here, okay? For circle P, so that center point is point P, okay, and it says it bisects AB, which is a segment, okay, it's a chord, at point X, right? So this just goes back to one of our chord rules, that because this is bisected, right, because that chord is bisected, what that means is that the angle formed between AB and XP has to be a right angle. So that must mean that this triangle, if you connect all 3 of those points, has to be a right triangle. Okay. All right, so let's really quickly look at the last two here. So number 7 is more of a like a definition type question, right? Like essentially who's right? So I have one person, Seth, that says that all diameters are chords. Okay. Then I have someone else named Sarah that says all chords are diameters. Okay. So the question is, which of those statements, if any, are true? Okay. And if you think back to our definitions of chord and diameter, chord is like that umbrella term that covers lots of different types of segments, but a diameter is a special type of chord. Okay. So it's very similar from uh, when we talked about quadrilaterals, right? I would say things like all squares are rectangles, but not all rectangles are squares. Because you can draw a rectangle that's not a square, right? But as you go further down the umbrella and as you get more specific, right, and you have more properties, right, then you basically have more names for things, right? Like a square is just a special type of rectangle, just like a diameter is just a special type of chord. So Seth here is right. Seth is correct. Okay, and then I have to justify my reasoning. So there's lots of different ways you can justify this, but I think the easiest way is that you can draw a chord that is not a diameter. See segment AB in number 6. Right? That's a perfect example. Okay, so you can draw a chord that's not a diameter, but you can't draw a diameter that isn't a chord, right? Another way that you could justify this is by saying that that diameters are special chords, right? They have all the properties of a chord plus a few extra properties that only diameters have. Okay, so that's another possible explanation. Right? Okay, so last one here, number 8. This is another one I kind of want you all to give a try on your own, but I am going to help you out a little bit, okay? Because the only thing that they told us is that the radius of this circle is 4. And they only labeled one radii for us, this one in the bottom left corner, okay? But I'm going to label a couple more radii for you and try to help you out here. So from here to here has to be 4. From here to here has to be 4. Okay, so that could help you. You could draw another radius in right here, and that would be 4. Okay, so keep that in mind because there's a couple of ways that you can solve this problem. Okay, so I have those radii that are all 4. Okay, and I have one other thing because I have a right angle right here. Okay, if we think back to our rule here that we saw in number 6, that I have, if this is a right angle here, then these two parts of this chord are equal. So same thing is happening here, right? So if this part of this chord is X, this one also has to be X, okay? So there's 2 different ways that you could solve this. Okay, you could either use the chord multiplication rule or you could use Pythagorean theorem with the right triangle. So I want you to see if you can figure out the value of X on your own. Pause the video, try it out, and then check back with me to see how you did. All right, folks, so go ahead and check your answer against mine. So I did this 2 different ways. I gave you 2 different options because there definitely was more than one way to solve this. So the first option was using that chord multiplication rule. Okay, so here's how I did that. I knew that since this part here okay, of this chord was x, and this was a right angle, then that means that this bottom part must also be x. So those were my two parts, 1, 2, of one chord. And then the other chord is this diameter that's cutting all the way through. One part is 2, and the other part is 4 plus 2, which is 6, right? So I have 6 times 2 equals x times x. You end up with the square root of 12, right? And when you plug that into a calculator, you get that x is 3.46, okay? Option number 2 was to use the Pythagorean theorem. That's why I drew this little right triangle in here for you in the top right corner, okay, with an extra radius, right? So I know that this leg here is 2. X is this leg. It's what I'm looking for in my hypotenuse because it's a radius, even though it's one that I drew in, right, is 4. Because all radii in this circle are 4. So you have 2 squared plus x squared equals 4 squared. I squared all the things, subtracted the 4 over to the other side, and again, you end up with x squared is equal to 12, right? So you end up with the same answer, that x equals 3.46, right? I love problems like this because it just goes to show you that there usually is more than one way to approach the problem. But the beauty of mathematics is if you follow the rules and the logic of math, then no matter which method you choose, you'll end up with the same answer, right? So that is it for this practice problems video. I know this one was a little bit longer, but I wanted to give you lots of different examples of how these segments can be used to, and these segment properties can be used to find different values and solve different types of problems. All right. So I will see you in the next video, everybody. Bye.